Okay, this is going to be video 1 for our energy and resources unit. So this is going to be our non-renewable resources. I'm going to go through and talk about what they are, and then the next video is going to talk about how they're mined. So that's how I'm going to divide that up. Okay, so there's tons of options for non-renewable energy right now. Not tons, I'm sorry, but there are more options than you think, especially when you divide it out into all the subcategories. But the primary categories are oil, natural gas, and coal. There's a lot of combinations. So these three are your primaries, and then like the oil shale and the tar sands, those are kind of options that fit back into one of these primary categories, but are getting more and more popular. And then nuclear energy kind of depends on who you talk to as to whether it's renewable or not. A lot of people make the argument that it's not. I'm going to continue to put it with the renewable energy options, but that doesn't necessarily mean that it is entirely renewable. I'm not convinced of that at this point. So this is kind of looking at where everything happens. If you're looking at, again, you're looking at your three majors. So you've got coal, you've got oil out here, and then you've got natural gas, which I'm not finding at the moment. Down here, natural gas, sorry. And then you've got more of the renewable stuff over here. So you can see a lot of options for energy, and there's a lot going on in one diagram, but those are kind of the options and where it's all, what types of places it would all come from. So starting out with oil. Oil is formed from large amounts of marine organic material, shallow water stuff, long time ago. Think back, way back to the beginning of the year when we talked about over time, what happened when we did that geologic time activity. When were you seeing the oil and the natural gas starting to form? So this was millions of years ago. Petroleum is a type of oil, so it's made up of hydrocarbons. We're not going to get too much into the chemistry of it right now, but has been very lucrative for Texas especially. We have a lot of oil wells in Texas. It's also obviously been very lucrative for the Middle East. So a lot of big money here. The U.S. has less than 5% of the world's population of people, but we use almost a quarter of the oil reserves in the world. So we are very high on the scale in oil and fossil fuel use. In 2006, it was about 20.6 million barrels per day. So that's about 7.5 billion per year. Most of what we're using it for is for transportation. So these are the demands. This is what countries want it the most. You can see the U.S. is the highest demand. A lot of the country is just not using, a lot of the world is not using oil. But then you also see Canada is using quite a bit, Australia is using quite a bit, and then over here into the Middle East, and China is using quite a bit, Japan is using quite a bit. And then stuff like Russia is down a lot farther on that scale. Okay, so the Organization of Petroleum Exporting Countries, they have 78% of the oil reserves, and most of what we have not proven but we think is there. 60% of our oil is imported from those countries. Canada and Mexico have provided 21%. The Middle East is a constant battle, and that gets into the politics of it. But we're getting our oil not from the U.S. but from other places. Okay, so this is where it's produced. So again, you see, we have a high demand, but we're not lit up. We're not producing a lot of it. So the stuff in blue is the one that belongs to those OPEC organization. There's a little bit of the North Sea. Here, hang on, let me go back. A little bit of the North Sea demands up here, and then Canada is supplying quite a lot. And then everywhere else, again, the Middle East and Africa is a lot. I'm sorry, South America is a lot more than you would think. Okay, so U.S. is the largest user, but we only have 2.9% of the reserves, so we're not really a big contributor right now. We peaked our production in 1974. Right now, most of it's found in Alaska or offshore in the Gulf of Mexico or California. Canada right now is making a big deal about their oil sands. It's a mixture of clay, sand, water, and bitumen, which is that really sticky, heavy stuff. Canada has 3/4 of the world's oil sands reserves, which are being used more and more. And then, so Canada and actually Venezuela also have a lot of the oil sands. So they are like the Middle East for oil sand. And then oil shale is another unconventional, oil shale is another unconventional resource for oil, found in the U.S. in like Wyoming, Utah, Colorado. But this is really not a good resource at this point. The technology is not really there yet. Huge environmental costs for mining it out, for getting it out, and then in areas where there's a lot of other natural resources that you don't want to interrupt, a lot of freshwater resources, stuff like that. Okay, in 1 barrel of oil, 42 gallons of liquid petroleum after it's gone through the refinery, so that's about 23 gallons of gasoline. The production cost is like so god-awful cheap, $1 to $2 per barrel for the Saudi Arabia oil, or $9 per barrel for the U.S. oil. Okay, so the trade-offs, I mean, you guys know all this already. We have plenty of it for right now. Remember, we've only got less than 100 years of oil remaining. So right now it's pretty cheap, but remember that's with huge subsidies. It gives us a very high energy yield, easily transported, low mining use, very good technology, very efficient at this point. You know, we've been using oil for a long time. Everything is in place. It's easy to use. It's pretty cheap, so on and so forth. The disadvantages, and what I find really interesting, is that all of the disadvantages match back to the advantages, which tells me that perhaps the advantages are not as clear-cut as we think. So, for example, yeah, we have almost 100 years left, but within 50 years, we're going to have to start finding new options, right? Low cost, but it's hugely subsidized, so it's kind of an artificial low price, right? It's cheap, so you waste it, you don't really start looking for alternatives, but if we take away those subsidies, oil would be a huge increase in price. Huge amounts of air pollution when it's burned, when it's released. Primary cause of air pollution, climate change, is the carbon dioxide that's burned and released, etc. And then increased water pollution. So the negatives really, when you look at it like this, seem to be much more dramatic than you would think. Okay, 43% of the global carbon dioxide emissions comes from transportation, comes from cars, from toxic chemicals released, from the carbon dioxide released, etc., etc. The water pollution, we've had, unfortunately, big oil spills. We've had accidents. We've had all kinds of stuff there. We're going to have our guest speaker come in and talk about that right after spring break. Land degradation when they're mining for this stuff. And then the byproducts are producing a lot of solid waste as well. Okay, so biggest polluters on the planet is transporting this stuff. So if we didn't have to transport it everywhere, our costs and our fees and everything would go down dramatically. So look at, and this is obviously, a problem here. They hit some bad weather, they whatever. But if you're looking at this, this is really telling, right? If we're transporting all this oil from the Middle East, how much are we spilling on the way? That one barrel there, that one container box there adds up really fast. Okay, natural gas is usually methane, CH4 chemical formula. They're liquefied and then removed as liquefied petroleum gas. So it supplies about 23% of the U.S. energy, 12% of the electricity, 52% for heat. We import about 20% of what we use, and then 90% of that 20% is coming from Canada. So we're primarily taking our natural gas from Canada. There's a bigger reserve of the natural gas, up to about 125 years, than there is of the oil. There are larger reserves, potentially. So again, you can look at that map, kind of look at where the reserves are, and notice that compared to oil, we actually have a lot more in the U.S. We have a lot more natural gas resources. Okay, The unconventional part of natural gas, so using it from the weirder places, landfills. We pull it from landfills, and that's something that's increasing recently and has been used very successfully. The methane hydrates, lots of resources, but we don't have a good way to get it out at this point. Very dangerous. So methane hydrates are generally under the water, right? This is like the hydrothermal vents, pulling it from there, but very unstable to release it, to recover it, and could have some potential really bad environmental effects. Okay, so this is where you'll notice where all those methane hydrates are found. The yellow is the ones that we've recovered already, and then we're inferring that there's more in those other areas. So you can see that there are potentially quite a bit. If the technology catches up to that, that may be something that would be useful later. Fracking is in the news a lot right now. It's incredibly controversial. I just want to give you the basics for right now, and we're going to talk more about it in class. But the basic process of fracking is releasing natural gas. It's recovering natural gas resources by injecting a really high pressure water or water and rock, water and sand, whatever mix, deep into the ground. That pressure causes the rock to fracture and therefore to open up the wells and recover the natural gas. So we're going to kind of look at the pros and cons of that later, and it's not a clear-cut issue. So what it impacts is groundwater, waste management, air quality, and water use, and it kind of depends on how you look at it. Sometimes it looks like, oh yeah, it's a lot less water use, a lot more water use initially up front, but then if you think about all the other costs associated with actually mining the coal, transporting the coal, burning the coal, you end up using more water overall than you do in the fracking. So it's really, again, not a clear-cut issue. It's which is why it's so controversial at this point. Okay, so coal. This is the Industrial Revolution fuel. This is what became incredibly popular, 150 years ago. It was used to generate 62% of the electricity in the entire world. We made 75% of the steel with it. So it's a sediment. It's coal used to be alive, right? So you started with plant and animal matter, which turned into peat, which turned into lignite, which turned into bituminous, and then anthracite. So I have samples of all that, and I will pass that around in class. You guys can see the different types of coal, and each different type has a different efficiency and a different amount of energy within it if you were to burn it. So this is the formation. So again, remember, you start with the living material over time, over pressure, over heat, and you turn into, so you can see where you would start with like the peat and then move into the subbituminous, bituminous, and anthracite. Okay, huge amounts of coal available, hundreds, thousands of years, tons and tons and tons of it, all stored. So you can see compared, the light blue is the coal compared to the oil or the gas. There is overall over the world a lot more coal than other stuff. Okay, we have 27% of the reserves, so the U.S. actually has a large amount of this coal resource available. This is looking at our production of coal, or our production of power plants and electricity by coal. Texas is a high one, and then you get up here as well. You see pretty much central U.S., right? And southeast, so middle of the continent, country, whatever. Okay. This is the process by which you are making coal. So you mine it, you pull it out, you have to pulverize it, break it down. You have to heat it, boil it, turn it, filter it, and then by that point you are back into the waste. So Russia's number 2, China's number 3, India's number 4. You guys can look through these numbers just to kind of be aware of what your top. So U.S. is number 1 for coal, and just be aware of your top countries. I wouldn't necessarily stress about memorizing the specific numbers, but I would know the top 4 and in what order. Okay, coal is the single largest source of air pollution. Huge amount of air pollution. Carbon dioxide, sodium dioxide, mercury, radioactive particles, all of that, which then leads to human health risks. And we're going to talk about these a lot more and in a lot more detail when we get to the air and air quality unit. So just know that most of this air pollution is coming from coal use. And then the mining problems, and we'll talk about how stuff is mined in the next video. But essentially, mining causes environmental degradation, and you can work on reclamation, you can work on putting stuff back to the best of your ability, but it's not ever going to be as good as it was before. Okay, so the trade-offs, advantages and disadvantages of coal. We have plenty of coal with a high energy yield, with a low cost, again, with the huge subsidies. Well-developed technology. And they're counting that air pollution can be reduced with improved technology, but I'm going to wait and believe that when I see it. I don't want to count that as it. Personally, I don't necessarily want to count this as an advantage yet. But that's, again, that's my opinion. So the disadvantages is the mining, is the air pollution, the water pollution, land use, health impacts, and then the carbon dioxide emissions. Okay, so there are technologies that are up and coming right now to work on making the emissions and the waste part of burning coal much less. And these are all included right here, so you guys can look these up. We're going to do some stuff about this later. Okay. So the emissions, coal is the highest. So we have the most amount of coal for a long time, but it also has the most carbon dioxide emissions and therefore has the most impact on climate change and air pollution and air quality.